You're most welcome on my YouTube channel Edu Point. In this video, we will discuss about the Gauss law or Gauss theorem.
Dear students, you are familiar with the electric field, but when we consider the plane in the electric field like this is the uniform electric field, and when we kept a small surface which have area vector ds by making an angle theta with the electric field E. In that case, the number of field line crossing this surface is called the electric flux, and this electric flux we can define by phi is equal to the closed surface integral of the electric field by the small area element, and this is equal to the E ds cos theta with closed integral. This is the electric flux. But what happens when we consider the charge enclosed by any closed surface? In that case, how much electric flux will we consider? For that, we have Gauss law or Gauss theorem. Okay, so according to the Gauss theorem, the statement of the Gauss theorem is that the total electric flux over the closed surface, the total electric flux over the closed surface in the vacuum is 1 upon epsilon naught times of the total charge inside the surface. This is the statement of the Gauss law. If we consider the surface which have area S enclosed the charge Q, then the flux phi is equal to surface integral of E dot ds, which is equal to the total amount of charge is 1 upon epsilon naught times. So finally we can write phi is equal to Q upon epsilon naught. This is the mathematical relation of the Gauss law. And the surface chosen around the charge is called Gaussian surface, and this surface which we have considered to calculate the surface integral is called the Gaussian surface. And when we select this surface, for that we shall avoid the charge on the surface. Okay, now we will try to prove this Gauss theorem. So for that proof of Gauss theorem. Okay, for this, first of all we will consider a charge plus q which enclosed by a Gaussian surface, and due to this charge the electric flux is radially outward in this direction, and at the point P in this direction which have the indicated by electric field E, and the position of the small area we will consider here, which have a small area ds and have the position from the charge is r vector. According to Coulomb's law, the electric field at the point P which lies at this surface is E is equal to vector E is equal to q upon 4 pi epsilon naught into r cap upon r square. This is equation number 1. And if we see here, this is the unit vector r which have the direction from the center of the sphere O to P. That means the unit vector have direction along OP. Okay, if we see the figure, this area element enclose the point at which we have to calculate the electric field intensity, and due to this, if we see this small area have the area vector along this direction, it is represented by vector ds, and it can be written as ds is equal to area ds with the n cap, where n cap is the area vector of this small area element. Then we can write here vector E in dot ds is equal to E ds then we can write here vector E dot vector ds. From this equation we can write here q upon 4 pi epsilon naught into r cap upon r square with the equation second is dsn cap, and after this we can write here q upon 4 pi epsilon naught into ds upon r square into unit vector r dot n cap. Since this unit vector r and unit vector n cap have same direction, that's why since unit vector r dot unit vector n cap is equal to 1, so E vector E dot vector ds is equal to q upon 4 pi epsilon naught into ds upon r square. You can consider this is equation number 3. And if we integrate this equation number 3 over the closed surface, on integrating over the closed surface, then closed integral vector E dot ds is equal to q upon 4 pi epsilon naught upon r square. This term we have taken as a constant q upon 4 pi epsilon naught into 1 upon r square closed integral ds, and this closed integral ds, this is the total surface area of the surface which enclosed the charge. In that case, since ds is equal to 4 pi r square, so closed integral vector E dot vector ds is equal to, here we can put the integration, closed integral of the surface in this relation. This will be 1 upon 4 pi epsilon naught into 1 upon 4 pi r square upon r square. So from this we can consider, and q is left here, so it will also you can write q upon 4 pi epsilon naught, and if you cut the common term, so you have obtained closed integral of vector E ds. This is equal to q upon epsilon naught. Since we know that closed integral E ds is the electric flux, since vector E dot vector ds, this is equal to phi E, so the total electric flux, you can consider this is equation number 4. So from equation 4 we can write here phi E is equal to q upon epsilon naught. So this is the Gauss theorem. If we consider there is n number of charges like q1, q2, q3 dot 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 qn, then total electric flux will be phi E is equal to q1 plus q2 plus dot 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 plus qn whole upon epsilon naught times, that means total electric flux is equal to sigma I is equal to 1 to n qi upon epsilon naught. And if we write this is equal to, since sigma over I is equal to 1 to n q is equal to qi is equal to total charge q, so phi E is equal to q upon epsilon naught. So this is the total electric flux. If the medium surrounded this charge have the dielectric medium of constant, if the surrounded medium have dielectric of constant k, then phi E is equal to q upon k epsilon naught. Okay, since we know that dielectric constant k is equal to the relative permittivity, and which is equal to the permittivity of the medium to the permittivity of the free space, then the flux phi is equal to the total charge upon epsilon. This is the electric flux when the charge enclosed by the medium, and when if no any charge enclosed by Gaussian surface, then that means q is equal to 0, then phi is equal to 0. That means no any flux will be considered. But when we consider this charge is situated outside the Gaussian surface, in that case no any charge enclosed by this Gaussian surface, that means the total electric flux with that surface will be 0. So this is all about the Gauss theorem. After that we will discuss about the application of the Gauss theorem.